All right, take 101. So today we're going to be going over day 2 on Advent of Code, and there's of course 2 parts on each day. The first part, we can skip over all the lore. The first part is, well, we get a bunch of lines, which we can get by opening the puzzle input, which I have here. It's 1,000 lines. Each line has different numbers. Each number is a level, and we have to determine if the level is safe or not by 2 criteria. Either they're all increasing or decreasing, or they differ by at most 3 and at least 1. So here you can see there's a 4 and a 4, and it's unsafe because it does not increase or decrease, and they have to by at least 1 and maximum 3. This one is unsafe because there's a decrease of 4. Decrease, it's fine as long as all of them decrease, which they do, but there's too big of a decrease, which is not okay. This one is safe because it decreases by 1 or 2. So is this one. It increases by 2 here, it increases by 3, increases by 1, increases by 2. So this one is safe. And what we have to do is to count, okay, how many of them are safe? How many of the reports are safe? And we have to give an answer, which I already have, but let's code it up in VS Code. So the first thing I will do is open the file. I have saved the text here. You just copy paste it from what's it called? From here. So I copied it and then I pasted it here, and there's 1,000 lines, as we can see. So the first thing I will do is open it. So we use with open. Let's see, where is it? It's here, and to make my life easier, I'm just gonna copy the path, copy the relative path, yes, and then I'm gonna set it to read, and then as file. So we're gonna open this file as a file, and the reports are the file.read lines. Okay, so we're gonna read all of the lines to get all of the reports. Now I'm just gonna make a safe counter because we're gonna make the loop soon. It's equal to 0. So right now there's nothing safe. For report in reports, we're gonna iterate through the reports. And what we're gonna do basically is just to check, okay, is this report safe or not? So that's exactly what we're gonna do. If is safe, then give it the of the report, then safe count plus 1. Safe count plus 1. This might look a bit confusing. Safe count plus equals 1. This is confusing because there is no is safe. We have to implement this ourselves, of course. And when I give it the report, actually I want to strip it. So to remove any trailing white spaces or new lines or anything like that, which we don't want. So what we have to do now is to just implement the is safe. Let me just print the safe count. Print safe count. So if we somehow implement the is safe function correctly, then great, we succeeded, and the program should work perfectly. So we will define is safe, and then we will give it the report, which it's expecting, and it's formatted or it's stripped, which is great. Now we have to get some new terminology. So they called it levels. Each thing in the file is a level, so I'm going to be calling it levels as well. Report.split. So now we split it, and now what we want to do is we want to make it into integers, because when we split it, they are still in the string state. They're still all strings. So let's make a int levels, and we make it a list, and then for levels, for level int levels, we want to do this int levels dot append int level. So we're casting whatever level is, and we're casting it to an integer, which in our case works because everything is an integer here, or at least we hope it is. If it's not, then of course how are we gonna calculate anything? Okay, and now that we've done this, we can just reassign levels to int levels, and now we have levels and they're integers instead of whatever the original was, which was in strings. So everything is formatted as we want it, which is great. And now let's remember, we want to make sure that it's increasing or decreasing. So what I'm going to do is I'm going to do a is increasing, and I'm going to set it to true to begin with, and then as we go through the test, it either sets it to false or it keeps to true. And now I'm going to make a is decreasing equal to true. So now, how do we test? So we have each level, and we have to iterate through them. So I'm going to make a for loop. So for I in range, the for loop is going to be of the size levels, and that's why I'm using range, so that I know how many times we have to iterate, and I'm going to use the length of levels, of course, to see how much we need to iterate. And actually I'm going to use -1 here, and I'm going to explain in just a second why. Because when we calculate, what I want to do here is to calculate the difference of all the numbers, because that's really what we care about. So we're going to calculate the difference, and since it's a difference, then we can call absolute, because we don't really care if it's positive or negative, we just want to know the difference. And if I go to the list, we go to the levels I plus 1, for example, plus, where the hell is the plus? Plus 1, and then minus levels I. And why did we do the range to be until levels -1? Well, because when we do this thing here, we go +1, and if we go to the last index, then there will be no +1, so we will get an error. So we actually want to stop at the almost last one. So that's the difference. Now we want to check if the difference is outside of the valid range. So how do we do that? If the difference is less than 1, then we want to do something. It means that, okay, this report is not okay, this level is not okay. But also, if the difference is bigger than 3, so we can just say or, and Python just does it at the same time. We don't have to put it in different lines. Or if the difference is bigger than 3, then we return false. So here, we directly know that this level is not going to work out. So we can directly return false. But if we, let's see, if we check for increasing or decreasing, we actually have to check both of them to be sure. Okay, if it's not increasing, then we have to check if it's decreasing, and if it's also not decreasing, then we know it's false. So we actually have to check both of them. So let's see how we'll do this. So we do a if statement. If the levels I is bigger or equal to, then levels I plus 1, I plus 1, then is increasing is equal to false. Okay, so now we know that it's not increasing, and we do the exact same thing, but the other way, decreasing is decreasing. So if levels I is smaller than the next one, so if this one is a 2 and this one is a 4, then it's not really decreasing, it's increasing. So if both of them become false somehow, then that's not great. It means that the whole thing is false. So how we're going to account for that is when we're done, we are gonna return is increasing or is decreasing. And this might look a bit confusing, is increasing, but what's happening here is, since Python returns true or false, meaning 0 or 1, it can also do a or operation, meaning, okay, if this is a 0 or 0, then it's going to return a 0. If this is a 1 or a 0, it's going to return a 1. If it's 1 and 1, it's going to return a 1. So this is sort of give me whatever is highest function, if you know about the OR operator. And yeah, that should be it. Let's see. This is the rest of our code. Let's clean it up a bit, and maybe it's a bit too big. Now let's think a bit about the time complexity. Let's run it real quick, actually, see if it even works. So let me see. Takes a second to run, but we get 686, and the answer was, let's see, 686. Oh, great. So we've coded it right. And now if we talk a bit about the time complexity, let's see. We have here a for loop, which is, of course, time complexity of O of n. Then we have another for loop here, but that doesn't really matter. This one is an important one, which is time of O of m. So m being just how many levels there are in each line, because you can have 1,000 lines, but one level per line, and of course that's going to be faster than 1,000 lines with 1,000 levels each. So the time complexity would be n times m, and then the space complexity, which means how much space it's going to take in memory because of all the lists and everything that we're making. It's going to be n plus m. So n to store all the lines, of course, and then m to just iterate shortly through here, through every line. So that's part one. Let's run it again. And yeah, it works great. Let me get rid of this. And now let's do part two. And part two is quite similar, actually. So I will just take my own code. What is part two? Part two is apparently they discovered some technique where they can allow up to one fault. So this one is inherently safe. This one is unsafe regardless of which level is removed. So let's say we remove one level. Can we somehow make the level safe if we remove any level that we want? So for example, this one is unsafe right now because you see it's increasing, but then it's decreasing. That's not good. But we can make it safe by removing the 3, then it becomes 1, 2, 4, 5, which is actually safe. So what we have to do is to do the exact same thing that we've done before, but add another check to see, okay, if we remove any of these ones, can it become safe? And I've tried to make it with time complexity, very good time complexity by just implementing it directly when we check the safety. But there's a lot of edge cases, and I try to give it like a second chance, so to say. So okay, if it becomes unsafe, then maybe it can become safe again if we somehow remove it. But there's just a lot of edge cases and a lot of troubles, and I mean it's still the same time complexity, so there's no reason to do that. But we're going to solve it. So what I'm going to do actually is I'm going to take all of this, let's see, not including, or yeah, including the return, and I'm going to tab it in so that I can put it inside a function, and I'm going to call it check safety levels. Okay, and now that we have this, it's a sort of a helper function, because why do we do this? Because we want to reuse the code later when we're gonna call the check safety function when we remove a single level from the levels. So we don't want to just copy paste the code. There's no reason to do that when we can just make a function. And how are we gonna call it? We're gonna call it by saying if check safety levels levels, then return true. Okay, so if check safety of levels is true, then we return true, of course. And it's only going to be true if it is true, if it is valid. So This is just adding another layer of complexity, but it's going to be useful a bit later on when we're going to do the extra check right here. So the extra check is going to be for I in range length of levels, and we're going to create a new list with one level removed. So if we think about the entire thing here, we're going to sort of iterate, okay, remove this one, is it safe now? 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 And we have to check every iteration, otherwise there is no sure way to know. So that's what we're gonna be doing. So we're gonna make a list called modified levels. Levels is equal to square brackets, and then for j in range length of levels. And why am I calling the same thing twice? Because I want to be iterating through sort of both of them, but leaving one letter out. And how do I do that? Or one number out. And I do that by saying if I is not equal to j, then we call well, then we add the modified levels. Then we add it to the modified levels. J. Okay. So this is how we're going to sort of iterate through every combination. Not combination, but removing this one, then removing this one, removing this one, removing this one, removing this one. And then we're getting this entire part, or this entire part. And what we're doing with it is we're going to send it to check safety. So that's what I'm going to do. We go outside the for loop. Now, if check safety. Did I misspell it? So if check safety of modified what? Right. I thought I was in this function here. I didn't even notice that I went outside of it. Okay, so now if check safety modified levels, let's give it a line of space to make it a bit more readable. So of course everything here has to be inside, let's see, inside where? Inside that is safe. Yeah, that makes sense. Then we're going to return true. Okay, so first we check normally, is it even safe to begin with? If it is not safe, well, it's going to return false, but we're going to keep going and give it every iteration. So we remove one, we remove the second one, we remove the third one, and it's going to check again. Okay, and actually now that I think about it, that should be in the for loop here. So because we're going to check, okay, removing the first one, removing the second one, so it should iterate through all of them. So this should be here. And then it's going to check the modified levels if they are safe. If they are safe, it's going to return true. If it returns true, then this whole for loop stops. And then we get a +1 here, which is great. And let's see what happens if we run it. And we get, let's run it again. We get 717. Let's see if that's right. And 717. Great. Now let's talk a bit about the time complexity as well. This one's a bit more confusing. Let's see. So yeah, we have time being, not this actually, this was from the previous one. So we have a for loop as we had before, and then we call isSafe, which iterates over the whole report. We call check safety, which is O of M. Yeah, and then we call check safety again for each check for each iteration. So we have to iterate through all of the lines, all of the levels. So if the level is 10 lines long, we're going to iterate 10 times, 10 digits long, if it has 10 numbers. So the time complexity is going to be time of O n, of course, because we iterate through every line, but then we multiply it by m, and we multiply it by m again because of these two for loops. So it's a bit unfortunate, but of course you could make the m's more efficient instead of m squared. But what I care most about is the lines as a whole. And then the space complexity is going to be O of n plus m. So not too bad, the same as the previous one. So the reason that the time complexity is a lot worse in this one is because we have to iterate again through sort of every combination to see, okay, is it possible without this? Is it possible without this one? And it's just another for loop that we have to make. So then it makes the time complexity worse. But if you just care about the n, so the number of lines, then it is still O of n, which is great. So yeah, that was today's challenge. Let me not forget about the leaderboard. If you guys want to join the private leaderboard, I will leave the code in the description. And yeah, thank you for watching and happy holidays.